Okay, in this lesson we'll cover class relationships. Okay, when you design classes, you need to explore relationship among classes because in practice your program may have more than one class. And then you need to know how those classes interact with each other. And then there are very well-known relationship among classes. The first one we call it as associations. Has a specific association called aggregation and compositions. Also, class relationship can be dependent to another one. So what we call is dependency. In inheritance, we can share certain things from one class to a subclass. So inheritance has a superclass and then subclass relationships. Sometimes we call it as a ether relationship. And then abstract classes and then interfaces. And also we have an inner class that refers to aggregation and composition relationships can be implemented with inner class. For this lesson, I will focus on associations. Okay, let's look at definitions of association. The association represents binary relationship between two classes. Okay, let me give you a very simple example. So we have a class called student, another class called course. We are looking at the class relationship between student and course. So we draw UML class diagram. And the association can be illustrated with a single line between two classes. So here what we are looking at is binary relationship between student and course classes. In the description, normally we put keywords saying that student takes courses Then we are going to look at multiplicity constraints. So this one specify number of instance. It means that student takes a course, or student takes many courses, or we can say that specific student take 6 courses. Those the specific number of instance we refer to as multiplicity constraints. Again, this idea is not really object-oriented programming. It's more related to object-oriented analysis and design. But I'd like to cover basic object-oriented analysis and design here using simple UML class diagram. Okay. So it has some rotations. And then let me just say as a description here. For example, first one, I did not specify anything on right hand side. We call it as unspecified. Which is good enough most of the time. But it's usually a good idea to specify. For example, student can take how many subjects per semester or per year, or can we not enroll anything, and so on. So we can use a star that represent 0 or more, or we can specify 0, 2 dots, and then star. That actually means exactly the same, 0 or more. People usually use a single star or asterisk rather than 0 dot dot asterisk. So let me copy, paste it here. So first one is representing unspecified multiplicity constraints. This one let me use 0 or more. That means the student can take no courses or many courses. So here when we say more, normally it refers to more than 2. We can say that there is more or many. So here I will use star. That's the most common conventions or rotation we use. So let me go to next one. So the first one is unspecified, okay? We can actually put number. That actually means exactly 1. So if I visualize it using a UML class diagram, student takes exactly 1 course. Next one, we use one dot dot star, one or more. Let me move it a little bit down here. So student takes one or more courses. So here's the number one compared to second diagram. Means student have to enroll at least one. Not like 0 dot dot star means student may not enroll anything, or they can enroll many subjects. Okay, let me move to next example. This one is 0 dot dot 1. You can guess that 0 or 1. So here basically saying students takes 0 or 1 course. We can also say 2 dot dot 4. That basically say between 2 to 4. I'm supposed to say between. So it's between 2 and 4. Means student can take 2 or 3 or 4 courses. Two comma 4 is slightly different from previous one. It means 2 or 4. So student can take 2 courses or 4 courses. This exclude number 3 or 3 courses. Okay, let me clarify. The first one say I can say that between 0 and 1. Again, the second one is basically same, between 2 and 4. So basically 2 courses or 3 courses or 4 courses. Again, that creates 0 or more. Let me write it down the meaning. So a student takes 0 or more courses. Next one is exactly 1. Again, you can write it down, same thing. Student takes exactly 1 course. Next one refers to a student takes 0 or 1 course. Next one, a student takes between 2 and 4 courses. Last one, say a student takes 2 or 4 courses. Okay, many of these concepts can be implemented same way or with a minor change. So let me just say here clearly exclude 3. Anything to do with the many, you may need to use simple data structure like array. Exactly 1 means you just assign value. Again, when you say 2 and 4 also, you can assign multiple values. Let's create the project, then let me demonstrate for you. At least the most important 0 or many or 0 or more multiplicity constraints. Okay, and then let me create student class, then course class. Here I create 3 classes, one for students and course, and then Java applications with the main methods. So as you can see, relation say student takes 1 or more courses. So let me change the name called John. So we have a student, John. May take a C and Java courses. So if you look at students class, again, straightforward students class here. We have a data field and constructors and methods. For data field, we say private course. Again, it's a multiple, so we say array courses, new courses. Here, I will just set it as 6 subjects or 6 courses per semester. Again, it depends on school, depends on university or college. Let me just say that 6 courses per semester. So here, more means a student can take up to 6 subjects. So we can translate that multiplicity constraints here. Again, I did not put students class with data field or method and constructors. As an example, I will illustrate some of them here. Again, John is going to enroll multiple courses. So for implementation, you need to know number of courses. Okay, let me put in one more data field called student name. For methods, let me select name so that you can have a get name and set name, which is a straightforward, so you can use code generation or you can type it. Again, next one, course. Okay, this might be slightly different. Okay, so if you look at get courses, that's okay. Let's say John enrolled for Java and C, we need to know 2 courses. So return array reference variable courses, that's okay. But when you add courses, set courses, here should be individual courses. Remove as. We are adding to array reference variable courses. Depends on locations, so I will say number of courses. Start from 0. Then I will add course one by one. Once I add 1, I will add number increase by 1. So that second subject will be added to next array data structure. Okay, I will visualize it here, so in case you might be confused. So we have array reference variable called courses, has 6 space. Index again 0, 1, 2 all the way to 5. So if we have one course based on course class called Java, then we can add that course reference variable to our data structure. So let me draw a small box here that represent course refers to Java and so on. So when you add the second one, it will be C. So that's why we can increase by 1 or number of courses, so that we know how many courses already added to courses object reference variable. Okay. For here, we don't need actually anything at this point. So data field, constructors, and methods. Let me go back here. So let's add course. There will be, let's say Java. So course we need a constructor with a string parameter. So let me go back. So this one we will say course name, default value. You can keep the Java documents, but I will remove it for spacing on my screen. Let me move method down there. Default constructor with one parameter called name, so that we can construct objects with a name in it. So that can be done, okay? This one I'll change to C. Let's say John also enroll C course. Slight different implementation on picture I say course, but I said here Java and C. Again, the get courses if you want to see the output. Again, returning, let me put one more method. Actually, two more. Say get number of courses, set number of courses, so that we can repeat number of times. So number of courses depends on John get number of courses. So if he enroll 2 courses, say 2. Let's print name called John. Again, we need a constructor. Again, we don't have one, so I'm using default constructor. So John set name. John, okay. Student name, okay, John, get name. Again, you reverse to diagram on your right hand side. John get number of courses, he will return 2, increase by 1. Here we says that courses, because it's going to return array value. Don't forget that's the array, okay? So we know that courses depends on index I. We can print. Again, it's going to return the course object reference variable. So that's why here says that depends on course class. There's a unique ID. So if you need course name, you're supposed to say course here dot get name, because each time it's going to return course object. So course object, you have one method called get name. Now you can see name of courses called Java programming and C programming. Okay, that was the first part. If you look at the diagram here, relationship between student and courses can be seen in 2 directions. So student takes courses. We can also write it down on left hand side. Says that usually put it on the top, so course has students. So in practice, we like to identify multiplicity constraints. So let me put it there. Takes. Here I will use has. Multiple constraints, I may say course need to have at least 5 students. And then we say many. Anything more than that, actually many. Of course, we can specify like 100 students per course. For here, I would just say 5 to many. Okay. So now we are looking at course class. Implementation is pretty much the same as a student class. So I will just type it. Okay. Course has 5 students, means again it has to be array of student class. If you can stop. Then you can implement it. Once you finish, you can resume. Okay, please try. Again, same, we need to count number of students. So int 0, that's okay. We are going to use getter and setter students. Again, we are adding student one by one. So there will be student with s. Here will be array. So students depends on index value. In this case, number of students. Then every time when I add students to course, I will increase by 1. Insert code, number of students, okay. So that we can keep trace of number of students in order to each course, okay, or course object. So look at the relationship here, 5 to many. So student courses can take 5 or more students. Let me add students to course. So we add John to Java course at this point. Implementation is pretty similar, so let me copy. So here should be course name. Let me just put some comments. Print add students for courses. This case for Java class. There should be a course name. There should be a course called Java. Number of students in order for Java class. So we'll say Java. Then the get number of students, okay. Again, here we are looking at students. That should be student 2, student class. And then here we are looking at Java. Then we will say get students. Almost same here. Java.get number of students. And then of course we are going to print students. Get name, again, same, get student name. So we can see that we have program is Java programming, one student, and then his name is John. So let me put some colon here. Okay, more readable. Okay, I guess we need to add one more student so that we can see whether it's actually working or not. So let me add another student called Jenny. Okay, and then here we say Java. Set student, this time I will say Jenny. Okay, so we add 2 students to Java course. Again, we know the number of students to Jenny is added to Java programming course. So as you can see here, multiplicity constraints is useful. Again, the decision is based on business rules. Actual implementation in Java might be slightly different with the actual analysis and design. For example, when we say 0 to more, we may use array. When we say exactly 1, you just assign value. 1 or more also need to use array data structure, for example. 0 to 0 or 1, you can assign only one value. Between 2 and 4, again, that should be array. 2 or 4, again, they can be direct. So one value, single object. Okay, for now, that's all. Thank you.